So friends, I hope you are getting, and let me start the session with one very interesting problem, 2 marks problem. In the GATE 2014 we had this problem. Wait a minute, let me take the pen over here. So the problem is given as, this is the GATE 2014 problem, right? And the question given as, let me draw it first, then I'll tell you what is the question. Here I have D1 like this. I have here 10 volt, perfectly fine. Here I have 20 ohm, okay. And this is the Schottky diode given over here. The Zener diode, other name is Schottky diode also, okay. So this is the question given, and this is the circuit of the question, and the question is, in the figure assume that D1 and D2 having a voltage drop 0.7 and 0.3 respectively. Let me change the pen and then I'll tell you. I'll write the values actually. So VD1 is given in the question 0.7, and I'll talk about the forward voltage drop across D2 will be given as 0.3. Okay, now question is, find out the status of D1 and D2. Status of D1 and D2. This is your question, and they have given 4 options. D1 and D2 both are on. Option B is given D1 and D2 both are off. Option C is given D1 on, D2 off. And option D is opposite of this, D1 off and D2 on. These are the 4 options given for this question, and the question is pretty clear to us. 1K is given over here. So friends, I'll tell you one thing here. When students are going to take this problem in their hand, what they will do, they'll take it 20K. No, please, this is about GATE exam. This is not simple exam. They are checking your aptitude, right? So you have to take 20 ohm because they have given 20 ohm. But in hurry and in speed, people take it to 20K. And in the starting onwards, they are taking the wrong circuit, so you'll get the wrong answer, obviously. Okay, and your options will be set in that way that whatever option you will get immediately, you will get the whatever answer you will get by solving the wrong circuit, you will get the answer in the 4 options. So please be careful. This is the GATE exam, okay? So here the 20 ohm is given over here. So let me start the circuit. So friends, for this question earlier, I told you one very, basic idea how to get the circuit problem. Okay. So here D1 and D2 are given. Both are connected in this way. It will be forward bias basis. If the potential, if I know the potential over here at point A and point B, I can be sure that what is the status of D1 and D2, but here I don't have any value VA and VB. So I have to find it, right? So here this is the condition like D1 and D2, if they are connected in parallel kind of thing. They are not exactly connected in parallel because 20 ohm resistance is given, but this is the kind of the circuit in which 2 diodes are given and connected in parallel. So remember in the last class I introduced one more method, and the method was opening the diode method. Opening diode. Open the diode from the circuit. Imagine that diodes are not available in the circuit. Here this diode is not available. Okay, leave it, forget it. The D1 is disconnected from the circuit. Disconnect it. Okay. Just assume that you are taking out this D1 from the circuit. Similarly, at the same time, you have to assume that D2 is also not in the circuit. So if these both are not in the circuit will be open. This 10 volt will be over here also, and the 10 volt will be over here also. Now, if you will connect the D2, if you will connect the D1, both will be in forward bias. So what you will take, see, the voltage drop across 0.7 is given, the voltage drop across D2 is given 0.3. So first we will assume that suppose D2 is working. Suppose, let's take D2 is working, okay, and D1 is not working. This is the one of the condition I'm taking over here. So this is kind of assumption. If assumption will be wrong, at the, at the end I'll get it that I was wrong. See, if this will be on, the voltage drop across it will be 0.3. Now in this case, this D1 is off. This is my first condition I have choose for this circuit, right? So this is the 10 volt given over here. Is it okay? So why I'm choosing this condition? I can take, if I'll not take this one, I can take it. 0.7 drop is given over here and the D2 is not working. That is one another assumption. So this is my assumption. You can do in any way by assuming the diode's condition, right, or a status. I assume that D2 will first forward bias, and definitely D2 will be forward biased first because the 0.3 drop will be there across D2, but across D1 you are getting 0.7. So let's take this circuit. Now, if you will find out the current over here in the circuit, so current will be 9.7, this is the 9.7 divided by, this is 10 minus 0.3, 9.7 divided by 1K plus 20 if I am right? So, when you solve this I, you will get 9.5 milliampere. Okay, fine. I don't have any problem with 9.5 milli. So what is the problem? Can I check my assumption is right or not? How? If I'll get the voltage over here, I can easily get that my D1 I assumed open circuit or reverse bias, the assumption is correct or not. Is it okay? How? First calculate the VA. What is the VA? Here VA is 10 minus 1K into 9.5 equal to VA. I applied the KVL in this loop only, this mesh, okay. Here VA is the voltage, right? How you can apply 10 minus VA divided by 1K equal to current. So here you are getting VA equal to 0.5 volt. Here the maximum voltage will be 0.5. Now tell me, will diode D1 work over here? We assumed in our assumption the diode D1 is in reverse bias. Okay. When we solve the circuit and we got the value of voltage across the D1, we are getting 0.5 and 0.5 is less than 0.7. See, 0.7 is given. We require 0.7 volt to on this D1 diode. So here in this case the diode D1 will not work. So our assumption is true. Our assumption is perfectly true over here. Is it okay? Means the circuit is working in this way. Now the question is D1, D2 on. So here in this case D2 is on and D1 is off. Simply we can mark now. D1 is off and D2 is on. Option D is correct. I hope it's pretty clear to you, right? So to solve for this type of circuit, what is the procedure? The procedure is first check diodes by opening it. In this case we open both of the diode and we check the status of the diode. We found that D1 and D2 both are working, both are in forward bias, right? But when we applied these two diodes one by one, what we got is that D1 is off but D2 is on. What we assume in the first case that we took that D2 is on and D1 is off, and our assumption was correct. But what if we'll do this circuit by D1 is on and D2 is off? Will it be possible? Let's check it. This is the D2, right? If you assume that D1 is on, so voltage over here is 0.7. Though this is the open circuit voltage, no current will flow in this circuit. So entire 0.7 will be here only. If across D2, the voltage of the P type is 0.7, will it work or not? Because 0.3 is the voltage drop given of the D2. Definitely it will work. So it is not possible that D2 will be off. It will be definitely for sure it will be working in the circuit. It will be forward bias. Okay. If it will be in forward bias, then case will be like this. The new case is like in your assumption, again we are adding something, and what we are adding is that your D2 is also working and the voltage drop is 0.3. Now we have to check, will it work or not? This circuit will be having any fault or not? So let me check it. This current I can found. Can I found it? Yes, I can see. If now we have to apply over here the node analysis. The voltage of VA is 0.7 given over here. So 0.7, this 0.7 minus 10 divided by 1K. Am I right? Let's take current into the diode will be obviously from this side because diode is working. So current is going from A to ground. So it will be plus I. Now what about this? This is nothing but 0.7 minus 0.3 divided by 20 equal to 0. Is it correct, friends? Now, you can find it. See, this is the minus 9.3 milliampere. Is it okay? This is plus I, and if you take it, the 0.7, 0.4, and this will come 20 milliampere. 20 milliampere equal to 0. So this I will come 9.3, so 10.7. So this will be minus 10.7. Your answer is minus 10.7 milli. What is this minus sign? Minus sign indicates that your current direction is completely wrong. Your current is not coming from A and going to ground. Your current is coming from ground and going to A. The current direction is this. If the current direction in D1 is this, will it work? Tell me. Will it in forward bias? No, it will be in reverse bias. Our assumption was wrong. Now we have to, clear it. So, by this circuit, we got D1 is off and D2 is on. Again, you can choose the option D is your answer. I hope this is pretty clear to you. Okay. Now, I'll take the next problem. The question is given as, this is the terminal. Here, they have given diode. Let's take it D1. This diode is going like this, connected with a resistance R over here. R is 2 points and B. The voltage drop across R is given. V out means we are taking V out across R. And these are the two terminals of R. And this terminal is connected with another circuit in which you have diode in this way, like this. And this is the input terminal. Input you are applying over here, V in this way. This is your circuit. Now the question is, for the circuit with ideal diodes, these two diodes, please assume ideal diodes because given in the circuit, the shape of the output V0, we have to find out the shape of this for the given sine wave input, and V in is given over here. Let me draw the V in, then we'll move to the V out, okay? So what is V in? V in is given over here is the waveform like this, starting from 0 and going to up to t, the time period of the cycle, and obviously this is 0.5 of t. This is the circuit given positive half and negative half of one cycle. This is your input is given, and they're asking what will be the output waveform, and you are having four options. Option A is given like this, the same as the input, say 0, and this is t, same as the input. Option B is also given, and in option B, this is the reciprocal of input waveform or negative of input, and that is t, fine. The option C is given over here is this much only, like this, and this is 0.5 t, obviously. And the last option we are getting like this only. These are the four options. This is the question, and the question is from GATE 2015. This is the GATE 2015 question. Okay. The question is, V in is given over here like this, D1, D2, ideal circuits, ideal diodes. You have to find out the V0. See friends, now we'll observe this in the positive half cycle. What is going to happen over here? In the positive half cycle, this will conduct. Okay, fine. We'll go to this side, and the current will go to this side, and D2 is also work because this is the entire positive cycle we are talking about. So the current direction in the positive half cycle is like this. Here the current direction is like this. Tell me the voltage drop will be. Voltage drop will be this I into R, but direction of the voltage drop will be like this. If you equate this voltage drop to V out, it will be in minus. So V out will be minus of input current into R. I hope it's clear to you. Right. Now, it's perfectly fine in the positive half cycle. What about in the negative half cycle? In the negative half cycle, the diode will be off. The entire circuit will be in cutoff. At the output, V out will get 0. Will get 0. Now, we have to draw the output input, right? So, this is your input cycle given over here. Plus and minus. Let me take it V in. Now we have to draw the output. In the positive half cycle, you are getting minus of input voltage. Is it okay? And that is minus. Minus means like this. Like this. And in the next negative half cycle over here, it is off. So which one is correct? The option C is correct. So this was very easy question based on the diode application. You have to know about the diodes, when it's working in the forward bias, when diodes are working in the reverse bias, and you have to apply those methodology in the circuit and have to solve it. This is, 30-second question. Only 30-second question they asked in the GATE 2015 and 1 marks. Okay, let me take another example. Let me draw the circuit for that. The question, this is the GATE problem, GATE 2011, and 2 marks problem, right? 2 marks problem, and the circuit of the problem is 1K connected with 3.7. Here I have Schottky diode or Zener diode, in other words. Like this it's given. Let's take it D1. Given in the question circuit also. It is 1K. Here you have D2. Perfectly fine. And here you have V0. This is your circuit given. Now what is the question? And with this circuit you are having some waveforms also given. Some VI characteristics is also given. Let me draw that one also. This is the current I. This is the current V. Is it okay? And let me draw the wave. Wait a minute. So it's given like this is given like this is 0.7 drop. Here minus 2.7 knee voltage is given, or it will be definitely the breakdown of the Zener. So this is given with this circuit. Now we'll check what is the question. The question says, assuming Zener diode D1, this is the Zener diode D1, has current voltage characteristics. D1 has current voltage characteristics as shown in below. On the right and forward voltage drop of D2 is 0.7. See. So this is the forward voltage drop of D2 given over here. They have given this is the Zener characteristics, and the D2 voltage drop is 0.7 given in the circuit. Now the question is, find out V0. Find out V0. Your options are also given for this circuit, and 3.7 volt. Option B is given 2.7 volt. C is given 2.2 volt, and D is given 0 volt. This is your question part. Now we'll solve it over here. Okay, let me change the pen color so it will be pretty clear to you and clear. So how we'll proceed it? I told you earlier, see, if you'll observe the Zener breakdown, so Zener breakdown VZ is given 2.7. Okay, this is obviously this is in the negative, because reverse bias. Zener diode is working in reverse bias only. So they are given on the minus 2.7 over here. Okay, so VZ is 2.7. And if we'll talk about the D1 forward drop, so forward drop is given 0.7. The diode D2 forward drop, it is also given 0.7. Is it okay? Now the question is, find out the V0. Now I told you earlier, if the D1 and D2 kind of thing, or in the parallel structure kind of thing is coming in the question, what you have to check, please open them. Please open both of them. You open them, what is going on over here? If you open them, the first step to check, step 1, open the diodes. Open. When you will open, the voltage over here will be 3.7. If 3.7 is the voltage over here, this D2 can be forward bias. What about D1? It can be break. They both are working in conditions. Zener diode works in the negative bias now. So here we get immediately 2.7 knee voltage or Zener breakdown voltage if the condition is 3.7 voltage is given over here. Is it okay? And the D2 is also working. Why? Because in this circuit now current will pass in this way. Is it okay? So D2 will be also in forward bias. Now step 1 is clear that both will be in forward bias. Now in the step 2, one by one we have to check. One by one you have to check it. Okay. Right. Now in the earlier one question we have taken over here, we have seen two diodes were working, D1 and D2. For the diode D2 the voltage drop was 0.3, but for the diode D1 there the voltage drop was 0.7. There we assume that D2 is on and D1 is off, and our assumption was absolutely correct for that question, if you remember. So similarly for this question also I'll do the same. See, if D2 is in forward bias, it will take 0.7 volt to work. But if you want to work D1, it will take 2.7 volt. 2.7 volt. Okay. So I'm applying the voltage at negative terminal. So it's by default minus 2.7 across D1. But for working of D1, I need over here greater than 2.7. Is it okay? So leave it. According to my second point, one by one I have to choose or check the condition. Let's take D2 is in forward bias. D2 is in forward bias. D2 is in forward bias. So you are getting 0.7 drop over here. Or let me clear it and make it very, neat and clean for you. So you will get, wait a minute. You can now show the battery voltage drop 0.7. At the same time, you have to open it. This is my assumption. If my assumption will be wrong, I'll get to know it at the end of the, when I'll solve it at the end, I'll get whether my assumption is correct or not. We have taken this open circuit or off or reverse bias. Okay, fine. In this case, forget about this now. In this case, the current in the circuit is, see the current. Can I find the current over here? Yes, I can find. The current is 3.7 minus 0.7, the potential difference divided by 2K. So this is 3.7 and this is 3 by 2K. So at the end you are getting 1.5 milliampere. If you are getting 1.5 milliampere and this is your circuit, assumed circuit, so what is your task? Your task is to check whatever you assumed is correct or not. You assume that your D1 is off. So let's check it, whether it's really off or not. How to check it? You have to find voltage over this point. Over this point, let me take pen first. Over this point, you have to find out the voltage. If that voltage is greater than 2.7, it means my assumption is incorrect. Greater than 2, if this is greater than 2.7 means the D1 will work in the circuit, but I assume this is off. Is it okay? But if V is less than 2.7, it means my assumption is absolutely right, correct. Below 2.7, the diode is in off state and I have chosen the D1 as the off state. So let me check it. So this part you can easily do now. How? You have the current in your hand. You have to find out the V only now. It's very easy task to you to get it now. Okay, wait a minute. So the current is coming in the circuit. Here it will make the drop and it will be 1.5 volt because 1.5 milli into 1K it will be 1.5 volt. So here the voltage is 1.5. Let me make it clear. Wait a minute. So current in 1K is, in this 1K, the current is 1.5 milliampere. 1.5 milliampere will make the drop of 1.5 volt over here. Now what is this volt? This volt is nothing but 1.5 plus 0.7. So your volt is 1.5 plus 0.7. See, the volt is coming 2.2. So voltage is coming 2.2. So 2.2 voltage is coming. What it means? That your assumption is perfectly fine, perfectly correct. Your D1 will be off always because the voltage at the point, this point or V0 point can't reach maximum 2 or beyond this 2.2 volt. It will be max 2.2. Okay, I hope it's very clear to you in this case. If your assumption is correct, everything is correct. Now come to the question part. They're asking find out the V0. Now you can say the V0 is 2.2 volt. Why? because this is the 2.2 volt you calculated over here, and this is nothing but the V naught. So your answer is 2.2. Is it any problem to solve this type of circuit, friends? Again, I'm telling you, if you are getting diode circuitry in the parallel form or in this way, what you have to do is, first step is to open them. Open them. In the open condition, if both are working, both are in forward bias, in the second step, check one by one. Is it okay? But sometimes what will happen when you will open them, immediately you can get idea that who will work, who will not work. Okay, so it will be beneficially for us. So sometimes in the step 1 only we can resolve the circuit, but sometimes, like in this case, we can't resolve the circuit by only this step. Yeah, we get to know that diodes are working in the forward bias by first step, but in the second step we have to resolve it, or we have to make sure that who will work in forward bias, who will in the reverse bias. So in the second condition we have to choose one by one. So while we were working on the second point, what we have checked over here, that who has the minimum drop. Here the drop was 0.7, here the drop was 2.7. So first I check the D2 will be on and D2 will be, or D1 will be off. So when I took this and I applied this condition in the circuit and I found the current and voltage in the parameters, so I found that whatever I assume was perfectly fine. After assuming or getting answers, V and I, all about this, you have to check your assumption is correct or not. So you have to check the voltage across open circuit. Whatever you open or make the reverse bias by your assumption, you have to check whether you are correct or not. If your assumption is correct, your circuit is true. Now you can find whatever they are asking in the question. So this is all about the this question. I hope you are getting the concept. But don't worry, if you are having still doubts, I'll clear you because I'm taking some more problems over here. The question is given. This is the GATE 1999 problem. GATE 99, okay? Problem, and the problem given as, let me draw the circuit first. This is the clamper circuit. Diode. Across the diode, I'm taking V0. Perfectly fine. This is the diode circuit. Here I'm going to apply the input V in. Perfectly fine. Okay. Now the question is the input voltage Vi. Here the Vi is given. The input voltage is given 4 plus 3 sine omega t volt. Okay. This is the Vi is given over here. Now, assuming all elements to be ideal, all elements are given over here is ideal. Let's take diode D1. D1 is ideal, okay? This is ideal. The capacitor is also ideal. Now, the average of the output we notice. The question is, you have to find out average value of output. The question is, find out the average value of the output. Friends, let's draw the V in first. It's a very easy problem, and your options are also given. The A is minus 3 volt, B is plus 3 volt, C is minus 7 volt, and D is plus 7 volt. V in is given 4 plus 3 sine omega t. If someone will say you, please draw the circuit for waveform for 3 sine omega t, immediately you will write. This is plus 3, this is minus 3. Is it okay or not? This is for 3 sine omega t. Now, but 3 sine omega t is shifted by 4 because you add some DC part. Some DC part, this is the 0 line, right? DC part is the 4. The 4 DC you have joined over here, you added over here. So this is 4 of DC, suppose. You have to add them. So at every point you will add the 4. Is it okay? This is the 0 number line. It will reach to 4 now. So this is 4 and your entire input will become like this. It will not touch the 0 because this is the maximum 4 plus 3, 7, and this is up to 1. So this is your number line 0, right? X-axis is given over here. So you shifted it. Now please come to this part. In the positive half cycle, what is the situation? The diode D1 will work. Definitely, when diode D1 will work, the capacitor will start to charge itself up to what value it will charge itself? Up to 7, because highest peak of the waveform is reaching to the 7 volt. So up to 7 volt, the capacitor will charge itself. Is it okay or not? Is there any problem with this? No, up to 7 volt it will charge itself, 7 volt. Because 7 is the peak value of the input. After 7 volt, the input will go down. When input will go down, means it will start its journey towards the negative half cycle. What will be the status of D1? It will be reverse bias immediately, because minus 7 is coming over here with this V in. See, after 7, the V in is going to decrease, right? Means 6, 5, 4, up to 1. Up to 1 it will decrease, then again it will increase, right? So let's take the capacitor is charged up to 7 volt, fine. Let's take V in is 6. It's still plus 6, right? Plus 6 minus 7, it will be minus 1 volt. For 5, it will be minus 2 volt. For 5, it will be, for 4, it will be minus 3 volt. Like this. The minimum value is 1. So for 1, it will be minus 6 volt. So for all time, the D1 will work as reverse bias. Is it okay? So once the D1 is reverse bias, your circuit is, let me draw it over here. Your circuit is like this. Here is V in and here is the output. Your circuit is like this, and your capacitor is charged up to minus 7. Is it okay? Now he is asking what is the V naught average value. So first find out the V naught. V naught is, if you will apply the KVL in this circuit, you will find minus 7 plus V in. This is your V naught. So minus 7 plus, what is V in over here? 4 plus 3 sin omega t. So this is minus 3 plus 3 sin omega t. This is V naught. Now what he is asking, he is saying that please find out the average value. V naught average value. Tell me one thing. The average value of sine waveform will be 0 or not. The average value of minus 3 will be minus 3 volt. This is the average value of V naught. So your answer is option A, minus 3 volt. I hope it's clear to you, okay? You can easily find the average value for this type of circuits. This is the DC part. This is average itself. But for the sine omega t or cos omega t function, these are the cosine and sinusoidal function. So the average value will be 0. Why average value will be 0? Because for one complete cycle, the positive half is equal to the negative half. So definitely average, you will get the 0. Is it okay to you? Let me take another example. And the question reads as, first I'll draw the circuit. The capacitor C1 is given over here. The input V in. Perfectly fine. When I'll draw it, you will understand which type of circuit it is. This is the D1. Let's take it D1 circuit, diode circuit. And here you have in this way D2. Here you have capacitor C2. Now the question is, find out plus minus VC2. Okay. So this is voltage doubler circuit, right? Correct? This is voltage doubler. Why I'm saying doubler? Because it contains two capacitors. So two capacitor means twice the input voltage will be at the output. Is it okay? V in is given. The V in is given to you, and V in is 6 sin omega t. So this is maximum and this is minimum, and this is the V in. If this type of question is coming in the question, you can immediately answer that it will be 12 volt. Why? Because you already find out that the circuit given over here is the voltage doubler. If this is voltage doubler, then VC2 will be definitely 12 volt or not. Tell me. Is it okay? But suppose you don't know this is voltage doubler circuit or whatever. So how to solve it? Okay, we are going to solve. This is positive half cycle. This is the negative half cycle of the input voltage. I'm sorry. Okay. So in the positive half cycle, D1 will be in forward bias, D2 will be definitely in reverse bias. In the positive half cycle I'm talking about. In the positive half cycle. Let's draw the positive half cycle circuit. So positive half cycle circuit will be looking like C1, it will be in forward bias. This is your input, V in. The circuit is like this, and this entire circuit will be open circuited because D2 is open. What we'll do for the open circuit or open branch? Open branch is always useless in the circuit. Okay, so forget about the open branch. In this case, the C1 is going to start charging now, and it will be charged up to the max value. So it will be charged up to max value. Is it okay? Once it is charged, and it will be fully charged when the input reaches to the 6 volt. Is it correct? Now at the next moment, please see over here, at the next moment the input is going to decrease. 5, 4 like this, 0 and something. So my task is to come up to 0 only. Okay. So at any instant of time in between 6 to 0, let's take the value is plus 5 suppose. It's plus 5 or minus 5? It's plus 5 obviously. So this is plus 5 at some instant of time. So at this instant, what will be the voltage over here? Minus 6 plus 5, definitely it will be minus 1 volt. Is it okay to you? So friends, if it will be minus 1 volt, immediately the diode D1 will be off. At the same time or the same moment, the D2 will start. So what it means? At the peak of the voltage, peak of the positive half of the input waveform, the capacitor will charge itself fully, and at the next moment, the diode D1 will be reverse biased. And what about diode D2? The diode D2 will be immediately in forward bias. So your new circuit is like this. Tell me, is there any problem? Any problem with this? In the first half cycle, when input is to 6 volt or the peak value, the capacitor charged itself. Once capacitor charged itself at the peak value and input going to decrease from the peak value, immediately the diode D1 is in reverse bias and D2 start to conduct. If D2 is going to start the conduction, the circuit will be like this. Now I have to find the voltage across this, and it's given VC2 over here. I have to apply KVL over here. This is V in, perfectly fine. And okay, this will be minus 6 plus VC2 equal to 0. So this will be kind of VC2 equal to 6 minus VC2. Sorry, V in. So V in will reach to the minus 6. Up to minus 6, the diode D2 will be in this same region, forward bias region. And the forward bias region, the capacitor will charge itself up to 6 minus 6 up to 12 volt. So this 12 volt will be the voltage across this. Is it okay? So 12 volt is the answer for this circuit. This is the voltage doubler circuit. I hope the voltage doubler is clear to you now. You can see more problems in Boyle's State book related to the voltage doubler. I'll take the next one. So the next question is given as, here is the circuit. The capacitor C1 is given over here. Input is applying. And here one diode is connected like this. The negative part of the diode is connected with the battery, and that is the 7 volt, not 0.7. This is the 7 volt. The input is given to you, and input waveform is like this. Like this. Okay, this is your input waveform. Okay. V in, let's take it V in. T over here. Now the question is, we have to find out, so here I'm taking V0, right? So the question is find out the V0 only, or waveform of the V0. The peak value is given over here 10 volt and this is minus 10. Okay. So friends, this is the question like clippers or clampers. Okay. But in this particular circuit, we'll shift the input. So who is the shifter, waveform shifter? That is the clamper, definitely, right? So V in is connected over here. So how to solve the clamper circuits? How to solve? Last time I told you the steps. The first one is find out capacitor voltage VC in its steady state. Steady state, right? And in its steady state means it will be fully charged. Okay, it will be fully charged. So when it will be fully charged, the diode, you have to assume in the first step itself the diode is working forward bias, short circuited. In the short circuited, the maximum value, the steady state value of the diode will be, the capacitor will be VC1. If you calculate 10 minus 7 equal to 3. 10 is the highest peak value of this input waveform, 10. So steady state means at the peak value 10 minus 7, so it will be 3 volt maximum. So 3 volt will be the steady state. In the next step, to solve the clamper circuit, you have to open the diode. Open the diode and find out V0. Is it okay? These two steps you have to follow in clamper circuit. First, find out the VC in its steady state by assuming diode in the working condition, or short circuit or forward bias. When you find out the steady state voltage of the VC1, for this question you have found that this is the 3 volt. In the next step, what you have to do is, let me erase it first. In the next step, you have to open the diode and draw the output V0 waveform. Okay. So in the next step, the V in is as it is. The capacitor is charged up to 3 volt. So mentioned there. So this is V in. Now the diode is in open condition. The diode is in open condition, and here you are taking V0. So definitely your V0 will be your V in minus 3. Your V in minus 3. Is it okay? So, but you can, easily get it that this will be possible in the reverse half or negative half. In the negative half only, this diode will be go to reverse bias. So your V in max value is minus V in. So this is minus V in kind of 3. So this is minus of V in plus 3. So you have to shift the V in by plus 3 and take it negative. Okay. So this is all about your clamper circuit, how to solve it. This is the output waveform. You can draw it. V in plus 3. You can add the plus 3 in the input waveform and take the negative of it. Okay. Come to the next problem. This is the GATE 2002 problem. And the problem says the 500 ohm connected over here like this. The 5 ohm directly connected with input V in. This is V in. On this circuit, I have D1 diode, and here I have the battery or energy source 7 volt. This is 7 volt. Okay. So this branch is completed. Now over here I have D2 like this. Here I have 1K. In the 1K branch I have 5 volt. Here 1.5. And here I have to take V0. This is your circuit. And in the circuit they have given V in. They have given V in. The V in is like this. This is your V in. The highest value of V in is 12 volt. And like this. Now the question is sketch the output. Okay, this is your question. Now how to start it? So our task is to find out V0. V0 is over here V0 is over here because they are directly connected with the wire. So can I short it this first? I will simplify this. Wait a minute, let me change the color first. Can I simplify this circuit first? If this is the point A, over the voltage is same, V0, why unnecessarily I'll take two resistors and one battery and kind of thing? I can simplify this by Thevenin theorems if you remember. So across this point across this point A and B, let's take A and B, I can resolve this circuit and your circuit will become, or your circuit will contain one voltage source in series with your resistor. So disconnect this circuit from this entire circuit because I'll draw the equivalent of this circuit. This is your circuit. By Thevenin theorem, I can draw the equivalent of this circuit. I'll find the equivalent of this circuit and then connect with D2 or from this circuit. Okay. So let's take this circuit out. This is 1K. This is 1.5K. Here the battery is 5 volt. And you have to find the equivalent circuit across the point A and B. You can do it very easily because this is the Thevenin kind of thing. You have to find 1 volt. So this is the open circuit voltage. So you have to divide this 5 over here. So 1.5K into 5 divide 1K plus 2. So 2.5K. So it will be K will get cancelled. This is 2. So this is 3 volt. So your Thevenin equivalent will be the voltage. Thevenin equivalent voltage will be 3 volt. Now come to the resistance. To find out the R equivalent of this circuit, you have to short it. 1K and 1.5K, they are connected in parallel. So 1K into 1.5K divided by 2.5, it will be, if you will calculate, it will be 600. Now you can replace this circuit by this only. Between A and B. See, the point is A and B. In this point A and B, the circuit should be like this. So I'll replace this. Okay. I hope this part is clear to you. Let me erase some part. Why it's clear to you? I simplify the circuit by Thevenin theorem. I attach the equivalent circuit across A and B. I have found the Thevenin equivalent voltage, that is 3 volt, and I have found the resistance also. My point was A and B. Is it okay? Between A and B, by Thevenin equivalent circuit, I have found. Let me draw it now. Wait a minute. Your circuit is now become, this is point A, this is point B. Between A and B, my circuit was 600 in series with 3 volt. Your circuit is very simple now, and your V0 is not changed. You are taking V0 earlier at the point A. Here also the point A is not changed, so you are taking your V0 at point A. Now let's check the condition of D1 and D2, what they are working. They are working in forward bias, reverse bias and something. Okay, so for this question, particular question, I'll go in the details and will show you how to solve it. So we are having D1 and D2, D1 and D2. We are having so many conditions. I have to check one by one. So for this particular question, I may have so many conditions like D1 and D2 both are in reverse bias. D1 and D2 both are in reverse bias, means the voltage here is more than voltage over here. Or in other words, I can say if the voltage over here will be 1 volt, so definitely D2 will be off because somehow the voltage is over 3 in the open circuit, if you remember. And over here also both will be in reverse bias. And in the second case, D1 and D2 both are in forward bias. Both are in forward bias. The same condition, if the voltage over here is 8 volt, so both will be in forward bias. And the next condition is that D1 is in FB and D2 in reverse bias. And the fourth condition is D2 in reverse bias and D1 is reverse bias and D2 in forward bias. For this particular circuit, this condition will not be correct. Let's check it. D1 is forward bias. D1 is forward bias. When it will be in forward bias? When this voltage will be 8 volt. When this voltage is 8 volt, the D2 will be definitely in the forward bias. Why? Because the voltage over here is less than the 8 volt. So this condition can't be true. So we have remained with 3 conditions only. 1, 2, 3. Simple conditions. We have to check one by one. Okay. So let's check first condition. Both diode D1 and D2 are in reverse bias. If they are in reverse bias, when this condition will be true. Let me erase some part. Okay, this is the diode. I'm taking them in reverse bias. I have to remove this. Let me remove this also. So your circuit, your new circuit will be, this will be in reverse bias, and this is also in reverse bias if I am correct. Okay, this is 600, this is 3 given in your circuit. Okay, we are perfectly fine. Now what we can find over here, we can't find the current in it. Why? The current will be 0 because this is the open circuit. So if you'll observe this circuit, this is the open circuit, there is a no current. Voltage over here will be 3 volt because no current, no voltage drop. And voltage over here will be V in. Is it okay? Now, V in is going to increase. So if both are in reverse bias condition, they are not going to simultaneously operate or conduct. Means they are not going to come in forward bias simultaneously. Who will come first in forward bias? The D2 will come first because at the end the D2 has 3 volt, but here the D1 has 7 volt. So if V in is greater than this, immediately the diode will, the V in is greater than the potential at this terminal, the diode D2 will immediately come into the forward bias. Let's take that condition. What will be the Vn at that time? If Vin, or you need to make the D2 in forward bias, just take it short circuited, and here in this case you can find out the V in over here. Okay, so V in will be, see, now your circuit is V in 500 and connected like this. You need to find out the current over here, and your current will be V in minus 3 divided by 1100. Is it okay? This is the current. This is the current when diode D2 will come to forward bias. We have seen the reverse bias condition. The circuit is like this. Nothing is there over here. Okay. But in the reverse bias condition, the V0 was 3. Here the V0 was 3 definitely. Okay. Because in the reverse bias condition, there was no current in the circuit. Simply I can take the output over here. So V0 was 3. Now from reverse bias, we'll come to the forward bias, but the diode D1 and D2, they are not coming immediately or simultaneously in the forward bias. One by one they are coming. First D2 is coming. We have checked that the D2 is coming in the forward bias when this current will be greater than 0. This current is greater than 0, my assumption of the current is like this, greater than 0 means diode D2 will work. Is it okay? So in this case, the V in should be greater than 1100 divided by 3. I'm extremely sorry because this 1100 will go to this side, it will be 3. So you'll get the condition V in should be greater than 3. And it's quite obvious, when V in should be greater than 3, then only you will get the D2 in forward bias. Okay, so what is the condition? The condition is, let me erase some part over here so it will be clear. In the case 2, the diode D2 will be in forward bias. The diode D2 will be in forward bias. D2 in FB. When it will be in FB, when V in greater than 3. So we have to calculate V0 in this condition. What is the V0 in this condition? If the diode is in operating condition, so find out V0. V0 will be, this V0 will be, first let me clear some part. This is the condition 2 I'm talking about. The diode is short circuited and the voltage over here is V0, and you have to find that. In this case, the diode D2 is in for reverse bias. Okay. So V0, you can apply over here the nodal analysis. V0 minus V in, U0 minus V in divided by 500 plus V0 minus 3 divided by 600 equal to 0. So when you will find out V0 in terms of V in, you will get 6 V in plus 15 divided by 11. This will be your V0. So this is the case 2. In the case 1, the V0 is 3. In the case 2, the V0 is this. I hope it's clear. First, the condition or case was both are reverse bias. In the reverse bias, we have found out the V0. Now, in the next step, we can't take both immediately or at the same time forward bias. Why? Because one by one they are conducting. Okay. First, the D2 is going to conduct. The D2 is going to conduct in which condition? When V in should be greater than 3. We have found this. When V in is greater than 3. So my intention or I am not interested to find out the V in. I am interested in what is the value of V naught. So I applied the nodal analysis in the case 2 and I found that V naught is 6 V in plus 15 divided by 11. Now I'll come to the next one. Now this voltage is going to increase and at one time this one will also in forward bias. Both will be in forward bias in the third case. In the third case, if this is in the forward bias, what is the input voltage V in and what is the output voltage V naught? Okay, because in any case we are calculating V naught because we have to draw the V naught circuit. Okay, so we are interested to calculate the V naught only. In this case, both are in forward bias. Both are in forward bias now. So when this will be in forward bias, this entire 7 volt will appear to the output. V naught will be 7 volt. I hope it is clear to you. Is it correct? Now we are having 3 conditions for this circuit. Okay. And 3 conditions are, let me erase some part, then I'll show you. So the 3 conditions for this circuit, the case 1, both are reverse bias. In the reverse bias, the V naught is, the V naught is 3. V naught is 3. In the first case, both are reverse bias. Okay. And both were reverse bias below 3. The voltage V in was below 3 because at V in equal to 3 or greater than 3, the diode D1 is going to conduct. This diode D2, sorry. Now in the next case, D2 in forward bias and D1 in reverse bias. This condition, we got this condition when V in was greater than 3, and at this condition we got V out was, the equation was 6 V in plus 15 divided by 11. In the third case, both were in forward bias. D2 were in forward bias. So sorry, D2 was in forward bias and D1 both were in forward bias. So in this case, we got the output 7 volt. Okay. Now we can draw the output. See, when I'm going to draw the output over here only. Okay. Let me change the color. The first condition, the V naught will be 3 volt when V in less than 3. So this is 3 suppose. This is 3 because V in is going to increase. Below 3 for this entire reason, this is the V in below 3. For this, the output is 3 volt. The output is 3 volt. I'm drawing the output waveform. Output is 3 volt. Okay. So remove this part now. This is not over here. Okay. Let me make it a bit larger so it will be clear to understand. Okay. Now I can remove this. So this is, the detailed study of circuit in which we are having diodes. We can solve it by checking one by one. This was the kind of, we have to draw or sketch the output. That's why I did in this way. So your input is given. Like this. The highest peak of the input is 12 volt. Now you have to draw the output. So I'll change the color of the pen. So below 3, V in is below 3, the output is 3. The output is 3. This is the output, okay. So output is 3. This is the below, and in the below the output is 3 maintained itself. But once the V in is greater than 3, this condition is fulfilling. Okay, I don't know about this condition. Come to the D2 and D1, they are in forward bias. When this will be in forward bias, we didn't calculate this, but it will be Vn should be greater than 10.33. So 10.33 is over here, suppose. So above 10.33, the output maintained 7 volt. So above 10.33, the output will be 7, and below this, the output will be like this. So it will be similar to this. When you will draw it, you will get the same kind of thing. Okay. So this is your voltage output. Okay. So this is your voltage output. Now these are the condition. You can do this problem at your home again and you can check it whether we are right or not. Okay friends. So this is all about the first unit, that is the diode circuit. In the next video lecture we will start the second unit, the BJT and FET. I hope the concepts are pretty clear to you. I have solved so many problems. Basically, I took GET problems only. So friends, I'll tell you one thing. Please do problems at your home. Okay. We'll meet in the next. Till then, take care and bye.